This is a brief tutorial on how to build your own thrust vectoring controlled rocket, and this video is specifically about the hardware requirements, and I'll talk more about the software aspect in a future video. Just a note, this project was heavily inspired by BPS Space's TVC system, so definitely check his videos out for even more info. Anyways, to start off, you must decide how big the TVC mechanism should be. I found that 74mm in diameter is pretty much the minimum. Anything lower, such as a BT80 with a 65mm inner diameter, is too small to allow the motor a reasonable degree of freedom. With a 74mm tube though, a 29mm motor can rotate up to 10 to 15 degrees in both the X and Y axis, which is more than enough. Now, for the servos, it's pretty much mandatory to use a microservo due to the size constraints. Both a metal gear and plastic gear servo can work, though they both have their trade-offs. I found that metal gear servos break a lot more frequently since they like to overheat much more compared to plastic gear ones, but at the same time, they do provide a bit more torque. It really doesn't matter which one you use, though I decided to use a metal gear servo because that's just what I had on hand. Also, I'm using metal servo push rods to transmit the servo's motion to the TVC mechanism itself, though you definitely could also make it work with something like gears. For the motor, you want one that has a long burn time to allow the TVC mechanism more time to operate. I'm using an ST's F15 engine due to its 3-second burn time, but also because it has a relatively low price compared to other motors. You want to make sure to use an F15-0 motor because it has no ejection charge, which is important because your flight computer would be above the TVC mechanism, and an ejection charge will obviously destroy it if it fires. With the F15-0 motor, you want to epoxy the end opposite the nozzle to make sure the motor won't damage the flight computer once it burns out. There are, of course, lots of alternative motors, and you can use a 24mm motor for more range of motion, although those motors typically don't have as long of burn times. Next, you want to decide how you will control the TVC mechanism. There are two options, the Arduino route and the custom PCB route. I'd mostly recommend the custom PCB route because of how much easier it is to design with, since you don't have to deal with a mess of wires. PCBs also just look a lot cooler and more professional compared to Arduinos. But for anyone who has little to no experience making electronics, Arduinos could be a wiser choice because it's a lot easier for beginners to get started with. I personally decided to make my own PCB for this project, and so I'll explain it in a bit more detail. First, every flight computer needs a microcontroller, and I decided to use an ESP32. ESP32s operate at a lot higher CPU frequencies compared to something like an Atmega 328. It's relatively cheap, and it also has built-in Bluetooth and Wi-Fi support, which was extremely useful since that meant I could build an app to help control the TVC mechanism. I'm using a BMP388 altimeter to help determine flight events such as when the rocket hits apogee. For the IMU, I'm using both a BMI 088 and LSM60 SOXTR. Just one IMU is fine, but I wanted to use two to try out sensor fusion a bit. I also have an LIS 3M-DLTR magnetometer, which can be used to determine the rocket's yaw, since you only get the pitch and roll from just an IMU. Yaw doesn't really matter that much for TVC, but I'm going to use it for some other projects I'm planning. For power, I'm using a TRS 7.4 LiPo, which is pretty much the minimum necessary to power the flight computer. Most other batteries won't be able to provide enough current to power the two servos, or enough voltage, or are too heavy or big. The battery is first connected to some diodes for reverse polarity protection, and I've got an AMS1117 to convert the 7.4 volts to the 3.3 volts that all the ICs operate on. I've also got 4 servo outlets, a buzzer, and 3 LEDs to help display info, and a micro USB to allow programming with a computer. If like me, you're also going to build your own PCB, to get it manufactured, I would heavily recommend PCBWay, the sponsor of this video. Not only does PCBWay have great customer service, but their ordering process is also very streamlined and intuitive. They make sure to update you every step of your order, and their manufacturing is also very high quality, with countless customization options to suit your PCB needs. Best of all though, PCBWay is very involved with the PCB design community, and they have lots of contests with cash prizes, and they also sponsor many projects such as my own. Make sure to check out PCBWay the next time you order a PCB. Now back to the TVC system, the last thing you need is a way to eject the parachute. Typically, people will eject parachutes with an ejection charge and E-match, but since I didn't really want to mess with black powder too much, I created a mechanical way to eject parachutes instead. It's a simple mechanism consisting of 4 springs that will push the parachute out of the nose cone. But again, there are many alternative ways of making ejection systems. That's pretty much it for the video. If you have any questions, just ask them in the comments and I'll try my best to answer them. I've linked all the PCB files, 3D printer parts, and code below in the description. Thanks for watching.